Okay, so my name is Dale Henreichs, and I work for Gemstone, and I've spent only the last year and a half working on Seaside with Gemstone. And just recently we announced the public beta, a year after we announced the initial beta. Today I'm going to talk about the Share Everything architecture for Seaside. Let's see, I guess it was about 2 or 3 months ago, in February, and Avi Bryant wrote a blog post where he talked about the Gemstone architecture relative to Ruby. And there was a comment on that post where somebody said, well, this Gemstone stuff with all the shared caches and that's really nice, but how do you do share nothing in this? That's a technology that was invented in 1994. And that comment basically, said, well, I think I should give a presentation on that. But if you go out and look for share everything in the web, there's not very much on web architecture for that. But anyway, I went back to Avi's blog and looked to see if that comment was there, and I didn't find it the way I remembered it. So either I misremembered a comment, or Avi went in and deleted the comment, or I was in a different universe at that point in time. Anyway, when you go to Wikipedia and look at Share Nothing, basically they talk about a Share Nothing system as a distributed computing architecture where each node is independent and self-sufficient. A Share Nothing system may partition data amongst many nodes or require every node to maintain a copy of the application's data. And then there's some debate about whether a shared database, clustered or otherwise, would be kind of share nothing. And it occurs to me that in some variation of this definition, Gemstone is a share nothing architecture. But anyway, this architecture is very popular, used in a lot of places. A lot of the web is done with a share nothing approach. But the share nothing approach doesn't necessarily talk about how easy it is to do development. And when I look at another quote about what to crystallize what share nothing is every time you need data, you hit the database. All right. So developers aren't the guys that are have an easy time dealing with this stuff. For Share Everything, I think as Smalltalkers, Share Everything is our life. That's the way we live. The image, we do all of our work in an image. The image is the database for most of the applications, and it's we're used to having all of our objects there, just a message sent away. And the whole idea of Share Everything is to basically make it possible to bring in scalability to a web-based application in Smalltalk. So if you don't know what GLASS stands for, it's Gemstone, Linux, Apache, Seaside, and Smalltalk. And what we do at Gemstone is we bring in transparent persistence, transparent scalability, and we attempt to preserve the intimacy of the image-based development for large scalable applications. Now in Gemstone persistence, we persist all objects that are reachable from a persistent root. This is basically identical to what you're familiar with in writing an image-based application. Use class variables or instance variables, and things that stay alive in an image will stay alive in a Gemstone database and be persistent. So a Seaside application written to run in Squeak using image-based persistent will move to GLASS, and you will get persistence for free. The persistence does have transactional semantics, where we do a commit instead of a save image or an abort to revert your image changes. And so in Seaside, to add transparent Seaside or transparent persistence to Seaside, we extended the Seaside framework. And that's an advantage to be able to have an application that you're working with and get running in Gemstone, as opposed to starting from the beginning and going, where do I put these commits anyway? And we didn't want to have to train people in doing that. So it turns out that what we do for Seaside is we perform an abort when an HTTP request is received by the Seaside VM. And then you do your processing in the Seaside components, put together a response, and before we send the response back to the browser, we do a commit. So in essence, you do nothing special to worry about. Will the things I do while processing the request get saved, because they will be. Gemstone, literally everything that is in a persistent root will be saved and shared amongst multiple VMs. So there's no need to embed transaction logic in your application, figure out where the commits belong, where the aborts belong. Everything is saved. So you can write your application as if you're doing image-based persistence. So when you look at scalability, so persistence is a single VM issue, but when you look at scalability, it's a multiple VM issue. Scalability for Seaside app means being able to handle additional load by adding additional resources without having to change your application. So that means more VMs to handle more requests, more CPUs, more machines, more disk to ramp up and meet demand. So basically the kind of approach we'd like to be able to do is go from a single VM Seaside application and scale it up to add Apache multiple instances running on multiple machines and not have to change your application. So this all sounds like magic, and if you're familiar with Gemstone, it isn't magic, and what I'm going to do is basically go through and give you some an idea of what the underpinnings and the technology that Gemstone brings to this game to make this kind of thing possible. So this is a picture I've got in the lower right-hand corner there. You have a picture of a Stone machine where it's running with a shared page cache, and the shared page cache you've heard possibly, if you've heard about Gemstone, you've heard about the shared page cache. I will try to give you an idea of what just goes on there and the extensions where we do storage. So the truth is that the shared image is the key to our scalability story. So what you can have is multiple VMs running on multiple machines operating on the same single shared image, all right? And the trick then is to keep things in sync. And as I said, we'll go through that. The image sharing is made possible in the Gemstone technology by an object table and the shared page cache. Object table may be new if you haven't, new to you, and I'll go through some of that. All right, so I've got an object graph here, and every object in Gemstone has, every persistent object in Gemstone has an OOP. So you've got the object graph, and I'm using small integers here, but you know, real OOPs I wouldn't be able to talk about. Objects are stored on pages. So you can basically take all of your objects from an image and toss them out and toss them onto a bunch of pages. And those pages are then written to disk and stored and loaded into the shared page cache. So, and the references for the network are done by OOP. So you have objects like object 1 up there as a reference to object 2 and object 3 by OOP and on page 1, and object 3 lives on page 2. So that's where the object table comes into play here. And so the object table maps OOPs to pages so that a VM knows where to find things. And so basically you have, on the left here, you basically have the same thing that you have on the right, and the right would be something in your standard Smalltalk image. So the pages, an object table is also a page-based structure, and so all pages are copied directly from disk into shared memory. And so that's what the shared page cache does. Multiple VMs can share copies of pages in the shared page cache. When there's an object reference in a VM, the object is copied into VM object space. So here we have a partial graph, or a partial object graph loaded into the VM. And in fact, this is one of the key pieces for Gemstone. If you're familiar with Gemstone, we talk about being able to have billions of objects, and your object graph is going to not be able to fit in memory in at any one time. And so the trick here is that partial object graphs can be loaded into a VM's memory, and you end up working on a working set of objects for that you're working on, and you size your VM based on the size of that working set, not on the size of the total object graph. And basically, if you do a reference, send a message to 1, it references object 3, and it references object 4. The objects are faulted into the VM on demand.
Down in front.
Yeah, so you can see here that again, but we only bring in the objects that are referenced into the VM. So now when we add a second VM, the one on the bottom would be pointing to an object table 1, and the one on the top is pointing to object table 2. And what happens here is we share, each VM gets an object of the root of the object table, and the rest of the object table structure is shared on disk and in pages. And so basically adding a second VM is give it a root, it can load a copy of the objects and the object graph that it's working with in its memory. So when you make changes in one VM, what I want to do here is go through the steps to communicate how they get updated in the other VM. So you start by in the lower VM here, pointed object table 1 has made a change to object 1, and it now references a new object 6. And when you do a commit, what happens is that object 1 and 6 are copied to page 3 here on the bottom, and we update a new object table 3, that has the new locations for object 1 and object 6 inserted in the object table. And you'll note that the VM pointing to object table 2 is still perfectly valid and has a perfectly correct view of the entire system. In fact, that's the words that we kind of use to talk about the fact that different object tables give you a different view into the database. And as VMs move forward in time, aborting, they get a new view and they update to the new view. So to see how an abort is done, I'm having the top VM do an abort. And so when it does an abort, it gets a pointer to a new root, object table 4, that shares the object table with object table 3. And the VM invalidates the original copy of 1. When you do a commit, we record a bunch of information about changes that have been made to the persistent objects, and the VM picks that information up and can use it. So here we've basically invalidated object 1 because that's the object that changed. Object 3 still sits in the VM object memory. It will go away by a garbage collection over time if it's no longer referenced. And so if object 1 gets referenced, the new version of object 1 is loaded into the top VM, and the new object 6 is also loaded into the top VM. So you can imagine that if a bunch of VMs are making changes to the shared object space, and they do commits, you can imagine that there will be collisions, and those are called commit conflicts. And I'm going to show here a potential conflict. We've got object table 2, the top VM changed object 1, and the bottom VM also changed object 1. So on commit, one of these guys is going to lose. And in a standard Gemstone application, the loser has to have application code to figure out, what do I do now that I've got a conflict, all right? And the truth is we have RC objects, which are reduced conflict objects, that make it less likely to get conflicts. But when doing an application from Gemstone, you have to figure out what are you going to do about conflicts. Unless you can guarantee that they never happen, which is also figuring it out. So how do we do this in C-side? So again, it turns out that, to remind you that when you abort when an HTTP request is received, and we do a commit when the HTTP response is ready to send. Well, if we do the commit right before we're ready to send, and there's a conflict, the commit fails, and in C-side, we just simply resend the HTTP request. And this works for a couple of reasons. One is nothing got saved, and when you do an abort, you go back to basically the latest view that's available. So you get the new information on the abort. The other thing that makes this work is when you write a web app, you have to deal with the fact that there may be old information in browsers that people are working with. So you have to write your application in the first place to make sure that someone that had the price from 2 or 3 days ago in their web browser, when they hit the I'll buy that, basically you have to fail if that price is no longer valid. And so you have to figure that out and deal with it. So what that means is, especially in a high volume application, is multiple people looking at pages are going to get the same view possibly, but when they all hit the button at a different time, there could be potential conflicts. And the nice thing is well, just retry the HTTP request. What if they were just a little bit later, all right? When they hit the button and didn't, because the conflict occurs when there's an overlap. And because we do an abort and a commit on an HTTP request, it's a very small window of time that we're dealing with for the web. So anyway, this works out really well. And again, if this kind of approach doesn't work, there are the RC collections that you can add. And the truth is if you get to a high enough volume, you will have commit conflicts and you will have hotspots. But again, you deal with that at the application level, writing Smalltalk code and figuring out how to adjust for that. So anyway, this is our scalable glass architecture, and I'm not sure if, hopefully you got an idea of what goes on here, because in my mind, this is the way the world goes. Objects are changed in one VM, they pop into the shared page cache, other VMs get to pick them up and use them. And if you think about, if you're familiar with the Seaside application, there's a lot of session state that is created by a Seaside application. And in Gemstone, that session state is persistent. And so when you round robin a request through Apache, we don't use session affinity for Seaside. So all of the VMs that you add on multiple machines can be part of the pool of VMs that you're sending HTTP requests to. And so the Seaside data, along with your application data, is shared across the entire image, or all VMs. So I've talked about transparent persistence. I've talked about a little bit transparent scalability. And what about transparent development? On the previous picture, we got 6 VMs out there. Am I supposed to come in and VPN in? How do I debug? How do I manage the system and do development in that kind of environment? And so I've got a picture here of the glass appliance that I'm running on this box, and hopefully it booted up while we were coming up. And what it shows here is I've got 3 VMs serving Apache. Okay, so that's 3 Seaside VMs that are round-robining requests amongst them. The 4th VM on the top is a maintenance VM. Again, if you're familiar with the Seaside architecture, when the session state is aged, and over time you go in and basically, after 10 minutes by default, the old session state, a session that hasn't been used in 10 minutes gets removed from the system. The session is expired. And so that's done in the Seaside world by when a request comes in, there's an algorithm for deciding do I look, a scan is made, and then things are expired. But if you've got 6 VMs expiring requests at the same time, that doesn't work. So this maintenance VM's job is basically to wake up once a minute and go through and expire any Seaside requests or Seaside sessions that are timed out. And for high volumes, that maintenance VM can get busy. He also, in the appliance, that guy also runs garbage collection. I run it once an hour, and I know anybody that's done, that does a mark for collect once an hour, anybody that's done Gemstone will sit down and go, what the heck are you doing there? But what I wanted to do was err on the side of caution rather than wait until there were 3.9 gigabytes in your 4 gig repository before running a mark for collect. So I guess that's an inside Gemstone joke. But the bottom line is it's a Gemstone system and people can go in and actually change that. So when I'm doing development, I log in with Squeak using GCI, and so the bottom VM here would be the development VM. So what we'll be looking at here in a minute is a system where I've got 5 VMs running as a single system serving Seaside and doing active development. So I'm going to go into the appliance and give you a demo. What I want to talk about are several things: auto commit, an object log, debugging, and the transcript. Auto commit in Gemstone, again, when you're in a development environment, you need to make decisions as to when you abort or commit because it's part of the persistent state anyway. Until about 2 or 3 months ago, you had to make that decision. But now, what has happened is we've changed the tools environment so that every operation you make, every menu pick, there's a commit. And so when auto commit is turned on, you're basically as if you have live Seaside VMs out there serving requests, you have the maintenance VM running, and then you have your development VM running. And as soon as you accept, that new code is then distributed out to all the VMs that are running. So it's as if all 5 VMs that are running are one image running as a standalone image. And we'll go through and show that. You'll be able to see that here. In terms of the object log, you've got 5 VMs, 100 VMs. It's a real pain to go through and grep through file logs to go find out things that may have happened overnight. And also, if you're trying to debug something, sometimes you will end up doing a transcript show or whatever to see what's going on. And which VM is that transcript show running in, and where do I look for that? So what I did was add an object log that is basically it's an RC queue all right, for the gemstoners out there. And RCQ is essentially an ordered collection that does that is conflict-free. So it won't create conflicts so that multiple guys can add to the object log. And then I put a C-side interface to the object log to show, so you can see these things. So what you have now is a shared log amongst as many VMs as you're running, and things are timestamped and shown, and you can see that. For debugging, you set up, you get a halt. What I wanted to be able to do was use your development image for all the debugging, no matter where things go. And so I'll show a halt, and I'll show the breakpoints. And finally, I'll do just a little thing with the transcript. Oops, I need to go to the So this here is the appliance, and it's just come up, and what we have here on this side over here is this the status. So we have the caches running. Here we've got three gems. This is the port 9001, 9002, 9003 of the port they're listening on, and then the maintenance VM, and everything's running, so I'm happy. Let's see. I'll put an object log over here. So this is what the object log looks like. What it has in here is essentially the information that, the startup information. So I have 3 VMs running fast CGI, and this is the PID that they're at and that they're running on. And this is, okay, I don't have the machine in this version. And then I've got the startup VM running, and this one here gives us the expired sessions, and I'm not going to go into detail. So let me go over to C-side. This is familiar. Let's go in and examples. Oh, that's right. Because I don't have a network. So go to examples. Oh, look at that. Goodbye. That's wrong. That's left over from me playing this morning. But so I will go take care of that. All right. Now, this is fortuitous, I guess. So let me log in. So now I've created the development VM, and this is the Squeak image running OmniBrowser tools. And the nice thing about the OmniBrowser tools is all of the logic is actually running in the Gemstone VM. If you're familiar with GDS, what we do is we replicate stuff into the client VM and use the client tools on objects in the client VM. And what we're doing here for Glass is the objects are all living in the Gemstone server, and we're using OmniBrowser tools to communicate across GCI to basically pass lists back and forth and menu items. And for when things pop up like menus, we're using client forwarders for that. So, counter. Now that's weird. Ah. I'm not even sure how that happened, because this is from the demo. This is why I didn't want to shut things down and restart. Oh wait, there's hello and goodbye. It's there. I didn't see it. I'm blind. So what I will do is kind of combine the breakpoint, set breakpoint in this method, and then we'll go in, because we can assume that maybe there was a calculation going on that caused hello and goodbye to show up. So I set a breakpoint, and when I set a breakpoint in the development image, I send a message using gem-to-gem signaling out to all the VMs that are running in the system, and they're told to set a breakpoint in the VM on this method at the breakpoint that I set it on. So now all the systems now have breakpoints set, and so it doesn't matter which VM. Again, I'm running with 3 VMs here. When I get this request, the request goes to Apache round robins. I'm not never sure which VM is actually going to field the request. So we'll click on hello. Here's your familiar C-side walkback. What I want to do is do a remote debug. If we read through this, it basically says go to your development image, and click on the debug button. I need to abort the transaction. So whenever we do a hidden abort, I always want to say, are you sure you want to do that? And I come up with a debugger. And it's this remote breakpoint method, so we'll scroll down to where render content on is. And so here's where I set the callback, here's where I set the breakpoint, and what I'll do is go in and edit the code and fix this. Save it. Now, this is one of the reasons the tools is the reason we're still in beta, because you notice the code is still there, but if I refresh, it's the actual code. So I need, that's on the to-do list to fix. So I press the proceed button in the debugger, come back to my breakpoint notification, click resume on the C side, and I need to do more debugging. Okay.
No, that's
oh, that's right. We
you
displayed
click the breakpoint after the headings.
That's right. I had it at the callback, so it had already rendered the 2 and then continued and restarted. So, but now I've got the hello and goodbye gone from the counters as well. So anyway, that's setting the breakpoint. And now the interesting thing is, let's go to the object log and refresh. And okay, what that was, what was confusing there, is what we were looking at before. The browser had cached that view for that particular thing, because you notice this list down here doesn't quite look the same. But anyway, because here's the information from the recent restart. But anyway, the continuation shows up in the object log. And it says over here we've got the breakpoint notification, what the URL was, and this is the PID of the VM that actually handled the request that caused the breakpoint. Now if I click on this over here, I bring up a Seaside Inspector on the WA object log entry, and in Gemstone, I throw the oops out everywhere, so that when you want to do an identity test, well, compare the oops. That's a hard thing to do otherwise. But anyway, so you can see all the information here. Here's the continuation that was used to, and in fact, this is how we do the debugging. So when you hit an exception in a VM, and what we do is we snap off a continuation at that point in time. And part of the error logic, you saw there was a special error window that came up. We sit and wait for something to happen. But we snap off a continuation and put it into the object log. When I came to the development image and hit debug, what we did is we scanned through the object log looking for continuations. And when we found one, we brought it up in the debugger and let you debug it, and then we did a resume. When we did the resume, we persisted the process that was running in the development image, communicated that back, so when you clicked on the resume button in the browser, the process that had been running in the development image was basically brought into whatever VM fielded the resume click, and then we executed the process and it just ran and responded back with HTTP request. So it's kind of this weird thing that's going on using Gemstone, but what it does for you as a developer is you don't have to think about, do I have 8 VMs, do I have 2 VMs? You know, don't worry about it, you'll be able to debug in relative comfort. In fact, here's the resumption process here that we can inspect. And we can go down in this and look around here. So, and this is one of the advantages of the object log, because it's basically just, you can add, if you're trying to figure out why things are going crazy, and instead of just doing out print statements and hoping you run enough information if things are very crazy. Because there are times when bringing up debuggers just doesn't work. But anyway, there are times when it's very useful to have it. Let me go back. I do want to go through one more sequence here from Seaside. I'll go back to, so I want to go into bring up a halt. Because again, you sit down, you click on the remote debug, go back to our development image, click on debug. Now I've got a list of 2 things that went on. The first one in the list is breakpoint notification. That guy's still in the object log, so he's there. I can actually click on this and debug it again, all right? So one of the things that you've got here is you can, you know, if you missed it the first time, you can come back and look again. But you notice there's no up arrow at the beginning of the menu item. You can't resume that one because there's no infrastructure out there. The halt, on the other hand, I can look at. And we'll just go through this one and just proceed. Come back over to here, click on the resume. To be displayed is what you expect, and that's what we wanted to have happen. Come back over to the object log. And now you see the two continuations sitting over here. So we've got the halt and we've got the breakpoint notification. If I want to get rid of these things, I just click on, you know, my one. I'm a UI genius, all right. So no, the nice thing would be is if people take these things and actually make them pretty. This is functional. Let's see, what else do I have? Yes, the transcript. So I've got a transcript down here. And so now that hits the transcript in the Squeak VM, but it also goes off and the ubiquitous object log gets it as well. So show you can throw objects in, so you can throw, and this actually writes things out to a file as well. And that's something that does go on. There's file-based stuff that we have. If the object log also writes things to the file, so that you can look at a file if you want to. I'm going to finish up here with. So talk about the futures and where we're going. I talked about the fact that, and I think everybody knows that Seaside is is stateful and can generate a lot of state while you're running. And when and VM size can become an issue in terms of how much stuff you're keeping around for the sessions. So one of the things I'm doing with Seaside 2.9, and I think Colin independently headed down this path as well, is looking at ways for reducing and possibly even completely eliminating the need to do some of the session state saving. If you think about it, if you're familiar with the Sushi app and you've got this basically page with links on it that go to another page that just shows what the product is, well, that page with links on it, in Seaside, every time you render that page, it generates callbacks and additional information that gets stored. Those links, if you look at the link, it's a unique callback for every single one of those. It doesn't need to happen. And so basically the goal is to look at things like that and make it possible to essentially write a Seaside app that could take advantage of that if you wanted to, of reusing some of that state. Gemstone 3, last night you got the full-blown talk about Gemstone 3, and these are some of the things that are going on for Gemstone, or that are interesting to Glass. One of them is non-translogged objects. Again, session state, there's a lot of stuff that can get recorded in session state. In Gemstone, we're taking an entire process and persisting it, so the fingers go out and collect a lot of information. But tran logging in Gemstone is done for recovery. If the system crashes, you don't want to lose data. And so things are put into tran log so that you don't lose data. Tran log is disk-based. It is one of the things that causes, that is a factor for performance in Gemstone. Session state has no business going into tran log. If the stone crashes, it's no big deal for people to come back and start a new session to get going again. So we basically come up with a way to identify, it's based on roots. We have a non-tran log root object that anything that's rooted out of that is not written to the tran log. So there's some savings going on there. And that's a general Gemstone capability. Native methods was mentioned last night. We improved exception handling. If you're familiar with Gemstone, we have a different exception handling mechanism as part of the VM. With 3.0, it will be ANSI exception handling. And so there's some real speed improvements there. And we're adding a foreign function interface, so it'll make it easy for people to add C libraries. And then going beyond, these are not promises. Yeah, get shot if I said that. But the next place to go. There is a limit to how fast a commit can be done. All right, and there's only so much you can do by not putting Seaside state out to not tran logging it and sharing it or reducing the amount. There's only so much you can do. And so the next level of scaling that we want to look at is techniques for sharding that basically allow you to have multiple stones coordinate data. And so a VM running in one stone can access data in another stone. And it makes sense. And again, the idea is have the VM keep track of that. So anyway, I'm done. Does anybody have any questions? How do everybody into the ground? Yes.
I have a question that's related to Seaside specifically.
Sure.
The non-tran log objects,
yes.
You're not writing them to the tran log.
Right. Oh,
What's the process?
so what goes on is we just simply skip the tran logging,
So
okay?
you're going straight into the shared page cache and
Right.
then,
And then those things are in the shared page cache, they get written out, so they're completely persistent, but they're not written to the tran log. So the trick is basically that when we restart the stone and do a recovery and do tran log replay, we take the non-tran log objects, it's a dictionary, and it becomes a new dictionary. So the non-tran logged objects disappear on restore.
so will we non-Seaside, Gemstone, non-Gemstone Seaside people have access to that?
You know, I think, you know, part of it is an issue with the GBS, right?
Yeah, we need to
You
think
know,
about it, yeah.
you need to
But
think
shouldn't be
about it,
a
but-
big issue.
But in the Gemstone, but yeah, it shouldn't be, because basically it's a different global dictionary that you're putting things in. And if it's rooted in that global dictionary, and so what that decision is, where do you hook it in the hierarchy? And then everything else is taken care of at the VM. So I'm assuming that it should be transparent for, you know, for GBS
We already
users.
have session level stuff out of System 30, System 22, but,
Yeah, there's
and
non-persistent
I don't
stuff.
know what I'd use it for, but I'm sure that if it was there, I'd come up with something.
Yeah, I mean, this, you know, that, you know, like for Seaside, the session state was just a natural. It's stuff that we want it to persist, we want it to be, and in fact, we don't care about it persisting, but we're using the persistence mechanism for distributing the stuff around the system. And there's one more, you know, as I say this, there's that little piece that garbage collection of these things. And with Gemstone, since you have basically non-VM resident garbage collection, the garbage collection of the Seaside data becomes an issue of, you know, a separate process doing it rather than it, you know, getting intertwined with normal HTTP processing in the VM. So, any other questions? Yes?
This is a VMware appliance?
What I'm demoing is a VMware appliance, yeah.
That's the way it comes when you download it?
Yes.
or-
Well, that is our preferred way of distributing glass, because setting up a stone, installing it, getting all the pieces running, I would say that we're solving the installation problems for that to make it easy, because we want to make it easy. I think we still have one more layer of work to be done to make it easy to start a system like is running in the appliance now, which is 3 VMs are running at one time, servicing an Apache, you know, being serviced from Apache. So we prefer people to go with the appliance just because it's simple to get things set up. But we do have Linux and Mac installations that you can just download it and do direct downloads with. So, yes.
Any plans to make the glass stuff available for other than Seaside?
Oh, absolutely. It is.
Or, I'm sorry, other than Squeak?
You mean the UI part? The we're kind of leveraging the OmniBrowser stuff that's going on, and I know there's other clients. If there was a client, an OmniBrowser client in another, you know, like in VisualWorks or Visual Age, then you would be able to use those VMs as clients. But we're focusing our efforts on making sure the Squeak stuff works. But the truth is that if you have Visual Age and VisualWorks, you will probably already have GBS, and you can edit and use the tools to edit code in Glass. You know, connect it, you know, just log in as a normal user. The thing you miss is Monticello. The Monticello tools aren't there.
The debug features?
Oh, yeah, the debug features aren't there. That's part of that browser. So yeah, you know, I mean, it's a matter of getting clients, and you know, it's a matter of resources again, and we're giving this thing away. So you know, and a large portion of the community. I mean, the people that we're looking at for Glass is not our existing, you know, customers. Not because we're ignoring our existing customers, but there are new folks out there that are coming to Smalltalk, and because of Seaside, and it's an opportunity to basically enhance Seaside with the transparent persistence and scalability, as well as, you know, expose people to Gemstone and expose it so that, you know, our existing customers have more people to hire to continue doing work, because, you know, that's an important thing. So that's been, you know, the initial focus, is to tap into that market, make it easy there. If we have success there, then we continue to broaden things. But there's plans. There are because it's Ajax-based on the browser client interface. We're internally playing with a Flex-based client for on the browser. So we are aware of, the desire to not require Squeak as, just as a GUI.
We've talked about putting Omni Browser, as the Omni Browser tools get better, it might become attractive to put the Omni Browser into GBS. It's unclear yet whether the benefits of that outweigh the drawbacks, but it's certainly one of the possible features.
Yeah, well, the thing too is that the Honey Browser stuff is just really the development side of things. I mean,
Right.
if you write your Squeak application or a Seaside application and some other thing, you get a Seaside application, you can deploy it in this because the Seaside part and the web part just works. We had got a nice note from Michael Perscheid of the HPI folks who did the tutorial in the first, I think one of the first Seaside books. And I asked him, he had been too busy to work with us last year, and he said, I'm interested in Gemstone, can I have a copy? I sent him a copy, and he sent me mail last week that said, we ported our to-do application from Squeak to Gemstone. It took less than 1 minute, and that was because we had to create date tomorrow, which wasn't in Gemstone. It only had date today, so we did that, and everything just worked. So it's possible to develop the Seaside application and other stuff and deploy it in Gemstone. And also, the reason we want to spread this, and the reason we made it free even for commercial use up to 4 gigs of data, is we want everybody to be able to use this. I mean, it's like Dale said, the people, our enterprise customers want people who know Smalltalk. We have enterprise customers running Seaside. They're interested in Seaside, and we need a pool of people who know how to do Seaside programming, who can then go on and either consult or be employed by some of these larger companies and actually make some money. So if you have a small website and you have less than 4 gigs worth of data, download it. Use the appliance. I actually have an open source site to help do some development of things to start it up and not the VMware things. We've had some people figure it out, just haven't coalesced it yet. So we'd like to make it as easy as for people as possible to start it up and run it on the Mac or a Linux box. And use it to their advantage for free.
Yeah, Paul?
Joseph DeCancel was involved in some things like this many years ago.
Right.
One of the things he had to do to make it scale well was he had certain kinds of requests that would only do aborts, they directed you, and they would not do commits.
Yeah.
Do you have any way of maybe on a request basis or maybe having a gem, redirecting to a gem that only does as a readable view?
The answer here is that within the Seaside framework, all right, there's no such thing as a request that doesn't require session state. Okay, so the session state needs to be distributed, and this is where I was talking about the futures for Seaside 2.9. Is I think that Seaside is the framework. If it was architected such that certain requests were going to reuse existing session state, then the request comes in and we would do an abort. And if no persistent objects get written during processing, then that commit is basically, it's called a read-only commit. There's nothing that happens. We drop the view, all right? So the thing is that's why I'm working on the Seaside 2.9 stuff, because that's what I'm looking for, is there are definitely opportunities in Seaside to not, you aren't doing anything. But the Seaside man behind the curtains, he's the guy that sits down and says, oh, I'm doing a ++ link. Let me go copy this again. And all of this stuff, and it really doesn't need to be copied, and that's the possibility. So yeah, because it's definitely, that's the next level of things, is we're going to gain a whole lot more performance by avoiding commits than making commits faster. Because there's work you have to do in a commit. So, any other questions? Yes.
Well, yesterday I saw Seabreeze. Today I saw Web Velocity. And now we've got Glass. How are they all tied together? Are they going to be tied together, integrated somehow? Because they're three different streams.
Well, it's Seaside.
I thought you were working on that name.
I wasn't familiar with the
Velocity is
Seabreeze.
using Seaside underneath.
Yeah, Seaside is the common.
Not the Seaside, so the commonality is that they're all basing on the same open source cross Smalltalk dialect library. So unlike what used to be the case, if you built a web application in Gemstone 4 years ago, and then you thought, yeah, I'd love to run that on Squeak, or I'd love to run that on VisualWorks, or I'd love to run that on Dolphin, you're just stuck. Now, if you write a Seaside application on Gemstone, you decide that you really want to run it on VisualWorks, you can do that. If you write one on Squeak, you decide you want to move it to Gemstone, you can do that.
Yeah, so I think it's the framework. The framework is the important thing there, because there's all, you come at Seaside and there's different value adds on top of Seaside, all right? And that's why, I think that's why there's different things, trying to solve different customer problems. But, so so Seaside would be the common. Any other questions? All right, thanks a lot.